In this video functional Python, we will look at how to call a function with a list or tuple of values instead of individual parameters. This feature is called unpacking argument list in Python. Here's a link to the documentation and also a link to the code for and slides of this video, so you can follow along if you want. They will be in the description. So let's get started. And in languages like OCaml and SML, all functions take exactly one parameter. And it's via pattern matching that it feels as if we are passing either a tuple or individual parameters. This is a very nice feature. So let me give you an example. You might not have learned SML, but the syntax is relatively straightforward for this example. Let's assume that we have a function f that takes two parameters a and b, and it simply returns the result of adding a and b. Then let's assume that we call f the way that we will expect with two parameters, so 1 and 2, and then it returns b. But let's create now a tuple. Let's assign it to the value, to the name p, and let's put exactly the same two values, 1 and 2. And let's call then f with this pair. Notice that parentheses are optional in SML. And this is the result. Just as we expect, the pair is split via pattern matching. The 1 is assigned to A, and then the 2 is assigned to B. And it just runs as expected. And so let's see how it's done in Python. Let's do it through an example. And let's assume that we have this function. Same as before, f with two parameters a and b, it simply adds them and returns the value. So if the traditional way that we will call it is this, so we call f with 3 and 2. So let's try to do the same we did with SML. Let's create a tuple t with 3 and 2, a pair, and let's try to call this function with t. This will generate an error because we're only passing one parameter, and Python doesn't have structural pattern matching in parameters, so it simply assigns t to a, and it realizes that we forgot to specify b, and because b doesn't have a default value, then it simply generates an exception. What we need to do instead is to call the function with star t. What this basically says is take t as a tuple or as a list, in fact they're equivalent in this case, and decompose it, assigning the values of the tuple in the same order to the parameters. This line of code 23 is exactly identical, or equivalent, I should say equivalent to 24. And this does what we expect. So the first call, line 11, prints a number 5 in line 29. Then we get an exception, the exception when we are trying to call it line 27. And then finally 23 and 24 output 5 as we expected. So relatively simple way to use it, but very powerful because we don't have to specify all the parameters individually. Okay. Now the other interesting feature is that we can use it with dictionaries. The syntax is slightly different because we're going to use double asterisk instead. And here's an example of how to use it. The dictionary will have two keys in this particular case, one for each one of the attributes. And the first attribute A will require that the dictionary has a key called A, and then the attribute B will require that the dictionary has a key with exactly the same name. And this line 11 is equivalent to calling this function in line 12. Okay, and we get the result that we expect. But there's a limitation with respect to dictionaries, and is that they must have exactly the same number of attributes as the number of parameters. Sorry, the dictionary should have the same number of elements as the number of parameters in the function, and the names of the keys of the dictionary have to match the name of the keys in the the name of the let me start again. The name of the keys in the dictionary have to match the name of the parameters in the function. So let's try something different this time. So here's our function, same as before. And then we create a dictionary and we only put A. we don't put b. If we call this function, we're going to get an exception, and we'll see the result of that in a second. So let me actually scroll down a little bit. Missing one required positional argument, b. It actually tells exactly which argument we're missing. So let's add b, and let's also add an extra value to the dictionary. Let's add c. So notice that c doesn't exist as a parameter in f. And let's try to call it. Now we also fail. Now we have unexpected keyword argument c. This does not work either. Okay, so essentially the message is that if we want to pass a dictionary, then the dictionary, the number of values in the dictionary has to match the number of parameters in the function. There are some special cases with respect to parameters with default values, but let's not worry about that, because I want to talk about the basics rather than the details of the feature. So in conclusion, unpacking argument list is very powerful. We can pass a tuple or a list instead of each argument individually. And here's a link to the code for this video. Thank you.